Hello and welcome to another episode of the EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in building and urban efficiency. I'm your host, John Sheff, Danfoss's Director of Public and Industry Affairs. You can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever it is you get your podcasts. I'm really excited because today we have Frank Ford, Director of Product Management for Danfoss Turbocor, one of our flagship technologies, really exciting technologies. And Frank and I are going to discuss where this technology is heading and the new VTCA 400 compressor. So Frank, thanks for joining me.
Hey, yeah, thanks for having me, John.
Yeah. So before we jump in with these questions about the new VTCA 400, why don't we just start with generally what is Turbocor, why is it different, and how does it compare to a traditional oiled compressor?
Yeah, so Turbocor is unique in that we are the pioneer and the innovator in the oil-free space. So for chillers, and we did that many years ago, coming out with the first compressor having magnetic bearings for HVAC. So the magnetic bearing with the permanent magnet and variable speed, all this technology combined together is what really is unique for Turbocor and led the way in oil-free for chillers.
Yeah, and this oil-free technology is so cool. There are so many advantages of it. The turn-down ratios are really great for variable speed applications and maintaining efficiency over a long period of time. I mean, I've seen studies where 10, 12, 15 years out, the efficiency is just about the same as the day you put it in, right?
That's exactly right. Yeah. So since there's no oil, there's no friction. No friction means no losses. So you don't have any wear over the lifetime. So it doesn't matter from day one through 10 years, or more, like you just mentioned, you're going to get the same level of efficiency out of that compressor. And we have done some studies to help show that.
Yeah, and total cost of ownership for the chiller is just is really impressive when these oil-free compressors are used. So it's just a very cool technology. So tell us about the new VTCA 400. What's new about it? What are the benefits?
Sure. So this is the first Turbocor compressor for use with low-GWP refrigerant R1233ZD. So a very interesting refrigerant. It's a low-pressure refrigerant, but it's an A1, and it's a high-efficiency option. So what we've done with the VTCA 400 is really taken this compressor, this refrigerant, in a new direction. So the compressor that we've come out with, really the biggest benefit is just the size. So you're going to get a high efficiency machine, but you're going to get it at about half the size of everything else that's on the market. So, and compressor size is really important. If anybody's seen any of the other options that are currently available on the market with 1233ZD, the first thing that they notice is that everything is much, much bigger. So the system is big, the chiller is big, it takes up a lot more space. And some of that, not all of it, but some of that has to do with the compressor size. And so by having a smaller compressor, we get to give OEMs a different option. It's easier for them to integrate. And what it also enables is that return back to a multiple compressor system. So when you have a single compressor that's quite big, taking up the entire length of the chiller, that's not really an option. But with the technology that we've developed on the VTCA 400, you can get back to multiple compressors, which gives you additional benefits. You get higher IPLV, you get redundancy, you get better turn down now because you're turning down based off of the capabilities of a single compressor out of a multiple compressor system. And the way that we've been able to do that to make the compressor smaller is this is the first compressor that has a hybrid design. So for HVAC. And hybrid basically means that we've combined two different types of impellers across the stages. So it's a two-stage machine, and we've taken an approach where we have a different type of impeller on the first stage than we do on the second stage. So the vast majority of centrifugal compressors out there use an impeller called a radial impeller. So radial is just really talking about the direction of the flow across the impeller. So it comes in parallel with the shaft, and then it leaves radially off of the shaft. And radial impellers are really good in that they're high lift, you get good efficiency out of them, but what happens when you go low density is that the diameter has to get significantly larger than what you would do with a medium density refrigerant. And that larger diameter requires a larger suction, which then makes the whole system that much bigger. So by combining different technologies, we're able to bring that back down to a smaller size. And whereas most of the compressors out there and most of the centrifugals are radial, there's a different type that's axial. Most people think of a jet engine whenever they see axial. And axial can give you a very high capacity and high efficiency relative to the size, but you don't get as much lift per stage, and that leads to a slightly narrower operating map. And if you were to take a axial and a radial, combine them together, you can get what's called a mixed flow. And mixed flow is actually what we put on the first stage of our compressor. So this mixed flow, you kind of compromise and you get a good balance now between the benefits of a radial and the benefits of an axial, but you're able to bring it down to a smaller size. So what's the big part of this new product that we patented is just combining a mixed flow impeller on the first stage with a radial flow impeller on the second stage.
Yeah, and it's very cool technology, and it's kind of even cooler that this was an outcome of kind of the refrigerant transition. Moving to a new low GWP refrigerant gave you the opportunity to redesign and come up with a product that not only is smaller, but more efficient and can be used in different applications, right? What do you expect to use this compressor in?
Yep, it's primarily going to be towards water-cooled chillers. So 300 tons with a single compressor, up to 1,200 tons even with 4 compressors. And even more than that, as many of our OEMs have taken the technologies that we've put out and combined 6 compressors or even more in some cases. So.
Yeah, and I think, you mentioned earlier the smaller footprint of the compressor. It's so important. I don't think people realize when you're designing these chillers, they're going in, for the most part, pretty cramped mechanical rooms. So the more power you can pack into a smaller footprint, I think the better for OEMs, right?
Yeah, you're exactly right. So being able to have a smaller compressor is a great option for OEMs. So they're going to have the ability now to package it in a way that can provide an overall smaller chiller footprint as well.
Yeah, I think it's just really cool, and being able to put up to 6 compressors in a row, I think the turndown is going to be outstanding on these machines.
Exactly. Yeah.
Yep. So when will we start to see this technology available in the market?
Yep. So we've started working with just a few of our OEMs that have been participating in development. This compressor and chillers using this compressor with low density are a little bit different than the majority of chillers that are out there from Turbocor OEMs, but the OEMs are starting to do their chiller design now using this new compressor, and so we would expect that we'll start to see some of these in the field towards the end of this year. And from Turbocor side, we'll start pushing access to this to more and more OEMs over this year and next year as well.
Wow, very cool. So traditionally Turbocor has been one of, if not the most efficient compressor on the market. We talked about the turndown and the endurance of efficiency over time. But how does this new style, the VTCA 400, compare with a traditional Turbocor compressor in terms of efficiency?
Yep. So this compressor, just like the other Turbocor compressors, is going to be very efficient, variable speed, great turndown. The efficiency that we're going to see off of this machine, based on ASHRAE 90.1 current standards, will be more than 10% on full load efficiency, and then more than 25 to 30% on IPLV part load efficiency based on a 400-ton chiller. So the benefit that you would get, or OEMs will be able to get out of this, is even higher whenever they do start combining multiple compressors, because you'll be able to operate each compressor through the range of operation at its most efficient point.
Yeah, and I think that, when you combine that level of efficiency with low GWP refrigerants, I think that, when we start seeing product innovation, these larger chillers are going to be at the forefront of what we're seeing in terms of combining efficiency with low GWP technology and getting, the most sustainable, most, environmentally friendly and operational friendly compressor and chiller on the market.
Yep, that's exactly right. So we're very happy to have this new product, give OEMs a different option, give end users a different option, but still being able to deliver a very high efficiency.
Yeah. Well, Frank, I think that's a great place to stop. Thank you so much for joining us. And do you have any final thoughts?
No, appreciate the opportunity to talk about this new product, and thanks for having me.
Yep. Thanks, Frank. This was a great conversation. I can't wait to see this product in the market. Well, that's it for this episode of the EnVisioneering Exchange. Again, I'd like to thank my guest, Frank Ford, Danfoss Turbocor's Director of Product Management, for joining us. And don't forget to subscribe to the EnVisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever it is you listen to your podcast. Lastly, if you enjoyed this episode, please don't forget to rate, review, and share with your network. Thanks for listening. My name is John Sheff, Danfoss's Director of Public and Industry Affairs. We'll talk to you next time.